All right, this is Precalculus, Chapter 8, Lesson 3 on page 538. In Lesson 1, we solved the problems, the trig equations, using our calculators, by graphing it on our calculators. You needed Lesson 2 before this lesson to understand that when we use inverse, that we're limiting the domains. For the sine, quadrants 4 and 1. For the sine and the tangent, quadrant 4 and 1. And for the cosine, quadrants 1 and 2. We limit the domain to get one solution. However, now we're going to want to know every solution. So we use the inverse to find the one solution, but we realize that there are a multitude of solutions to the original equation. Because the original equation typically looks like, sine of x equals whatever, 1.52, right? We use inverse to solve for the radians, right? But in the original, x really has infinite numbers of values, okay? So you had to understand inverse before we could get here, all right? So, let's just work through these. If I'm looking at this one, what quadrants, okay, I have to solve this by using inverses. But when I use the inverse, what quadrant am I in? Okay, particularly for this one, the first. Okay, I should start with the cosine. All right. So I'm going to draw a cosine curve. And I'm going to draw it also negative. Okay. All right. So that this, in the original, this is quadrant 1. What is this?
Quadrant 4.
Quadrant 4. So 0.6, this is 1, right? I don't know, 0.6 is here. But 0.6 is also here. Right? Such that if I go forward, that's this concept right here. The ratio of any whole number, positive rather, radians is always equal to the negative if I go backwards on the unit circle. Okay? Got it? So that's the two solutions I'm going to use for the cosine. I'm going to go forwards and I'm going to go backwards. All right, someone do inverse cosine. Do this in your calculator and tell me what you get. 4 decimal places. 0.927. All right, so one of the solutions for x is 0.9272. So if this were 0.6, then this would be 0.9272. Got it? Make sense? But it repeats. This is going to repeat every 2k pi, right? But there's another one, and it's the negative. So x can also equal the negative of that plus 2k pi. Because our calculator's never going to give it to us over here.
Couldn't k just be a negative number? And then like...
Right, but it won't give me the same one. Okay, so can I solve for what this one is? What this number is right here? Yeah, I can do, what's this? Plus 2, I'm only going over 1 pi. Okay, what is that? What is that plus 2 pi? Somebody do that. Negative 0.9272 plus 2 pi in your calculators. What do you get?
5.3
5.3559. That's what that would be. And then to get here, I would take this number, 0.9272. To get to here, I'd add another 2 pi. That's why we do the plus 2 pi. Okay, I'm going to keep drawing it. Got it? To get here, I'm going to take this one. Yes! Yes! You get it? Kind of. To get from here to here, I'm going to add 2 times 2 pi, or 4 pi. It repeats it. Do you see that? So by covering these two, both the positive and the negative, and adding 2k pi, I've got every possible solution.
So you're just doubling it every time?
2k pi, I'm changing k. So it was 0.9272 plus 2k pi. So I'm adding 2 pi, I'm adding 2 pi. Yes.
How'd you get 5.955?
Okay, I took this one was negative down here, was negative 0.9272. So it was x equals negative 0.9272. I added 2 and I made it just 1, K1. I added 2 pi to it to get to there. Because the distance from here to here is 2 pi. So it repeats it. 2 pi, another 2 pi, another 2 pi. And it repeats it from here. Another 2 pi. Do you see how it repeats it at different places on the circle? Okay, so I'm going to redraw this. All right, so the ones over here repeat. Does that make sense? And the distance between them is 2 pi. The only one I'm going to find is this one here. So that's the cosine of negative x. And then the ones on this side also repeat. And the distance between them is 2 pi, another 2 pi, another 2 pi. It goes in both directions. I can go backwards because it's repetitive. So once I find this first one, I'm just going to do the negative of it and then add 2k pi. So the cosine is the easiest when it comes to solving, when it's not on the unit circle. The sine is a little harder because we're limiting it to the first and the fourth quadrant. All right, so let's draw the sine curve. Okay, let's just do that. All right, this is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. This is, 4 pi over 2? 5 pi over 2. This is another half of a pi. 6 pi over 2, which is 3 pi. All right, let's just look at this one. Let's say, let's go back one because we got to go to the negative pi over 2. Let's say I'm looking at the sine of x is 1/2. What's the value of x here? Counts up, so it's pi over 6. Counts up, it's pi over 6. All right, I put it kind of high up there. But all right, so looking down, it's pi over 6. In quadrant 2, what is it? What is it? 5 pi over 6. So here it would be 5 pi over 6. Where would it be here? So 2 pi and another 6. That would be 12, 6, and another 6 would be 13 pi over 6. And here, where would it be?
17 pi over 6.
So it's 3 pi. How many 6 pi is that?
18. So it's 17.
Then take one away. 17 pi over 6. Okay, let's look at this. We start at pi over 6 and go to 13 pi over 6. What's the distance between pi over 6 and 13 pi over 6? 2 pi. So if I can just say x is pi over 6 plus 2k pi, because it's going to repeat, right? Okay. What's the difference between 5 pi over 6 and 17 pi over 6? 2 pi. So I could say x is 5 pi over 6 plus 2k pi. All right, so all I need is those two. You agree? What's the distance between these two? Look at this. Okay, so let's make x pi over 6. So the sine of pi over 6, does it equal the sine of pi minus that? Do I get to 5 pi over 6 here?
Yes.
I do. I get both of them if I just know this concept. You got it? Do you kind of see this?
Yes.
So these two are important concepts. The cosine of x equals the cosine of that negative x. They're the same. The sine of any angle is going to equal the sine of pi minus that angle. Because always these two will be a distance of pi. You see that? It's kind of nice to know that. It's very nice to know that. Okay, now let's look at example 2. What time is it?
It is 10:40.
Okay. Oh, man, that's good. Okay. All right, so let's apply that in example 2. All right, the sine of x is negative 0.75. What am I going to use to solve for x?
40 quadrant.
But I'm going to use inverse, which is going to put me in the fourth quadrant, right? It's not on the unit circle. 0.75, 3/4 is not on the unit circle anywhere. So we have to use our calculators. And it better be between negative pi over 2 and 0 because we're in that fourth quadrant. So it better be less than 1.5-ish, right?
It's minus.
Stop it, Isaac. Raise your hand.
0.8480.
Should the calculator be in degrees or radians for this?
Yeah, Isaac.
Radians.
You gotta raise it. Six. You gotta roll.
5 or more.
All right, so x is negative 0.8481 plus 2k pi. Right? We're solving for the x. Can I solve for this one? Yes.
Yes.
I take pi minus this number. So it's going to be pi minus a negative. What is that?
It's plus.
And so what is it?
It's 3.8481.
Pi plus that. Pi plus that. You see how I'm figuring out my other radians?
3.9897.
So once I get one solution for the sine, I'm taking pi and I'm subtracting that solution to get to my other one. If this were the cosine, what would it be? Just be the opposite of it. So it'd be positive. You kind of understanding this? Okay, the tangent's easy. Tangent only ever has one solution. Sine and cosine always has two. And the distance between them is always 2 pi. The tangent only has one, and the distance between the next one is always pi because we're in the tangent curve. And everything repeats. Pi. Got it? Okay, so if I were given the tan of x is 3, how do I solve this? Just do the inverse. Inverse of 3, what does that equal? In radians. Somebody do it for me.
Is it 1.2490?
Plus k, almost wrote 2, plus k pi. Okay, I want everybody to look. You need to know this. It is okay for the number, the ratio, to be greater than 1 or less than -1. But what if I had this? Is that possible? Why is that not possible? Yep.
Does it have to be between -pi/2 and pi/2? If you were to find
The x, when I do the inverse, but why can't the ratio be 3?
because the curve goes to 1 and negative.
That's correct. So if you did inverse 3,
It says domain error.
exactly, your domain error. You have not limited your domain. That's correct. It's out of its domain. All right, so that is also true
Got it.
with the cosine. Everybody look, sometimes there's going to be no solution because you're going to end up with something like this, or you're going to end up with something like that. If these numbers are smaller than -1 or greater than 1, there are no solutions. Got it? All right, look on the bottom of the page below example 3. How many times is the sign +1 between 0 and 2 pi? How many times? 1. So if you come up with the sine of x is 1, you're only going to have one solution between 0 and 2 pi. How many times is the sign 0
Bless you.
in one period? It starts at 0, it goes up,
Twice.
hits 0 at what?
Pi. Oh,
Pi.
pi.
At pi, and it comes back to 0 at.
2 pi.
So if this were 0, what would be my x? X equals,
3.
1. Oh, wait.
okay, when did you say it is? It's at, it equals 0 at
The origin.
0, it equals 0 at
Pi and 2 pi.
pi, and at 2 pi. All right, so what would your x be? What's the distance between all of those? Does it change?
Pi.
It's pi. So you could do 0 plus k pi. You could do pi plus k pi. Do you see how -1, 0, and 1 are different from this?
Yes.
Got it? Okay. How many times in one period does the sine equal -1?
Once.
Once. Where?
Negative. 3 pi.
3 pi over 2. So it would just be 3 pi over 2 plus k pi, 2k pi. All right, cosine. How many times is the cosine 1? And where is the cosine 1?
1 at the or.
At 0. Before it ever moves, it's 1, right?
So it'd be 0 plus 2.
So it'd be 0. When does it go back to 0?
0? Or 2 pi?
At 2 pi, right? This would be 2 pi. This is 0. So if I asked you the cosine x is 0, it would be 0 plus 2k pi. Okay. What about 1?
Yeah, 1. At pi over 2.
At pi over 2. That's right. And it repeats it, right? And then negative 1 only has 1. Got it? Okay, so you have to think about that. So 1, 0, and negative 1 are different than this for the sine and the cosine. Just thinking about the curve. All right. Let's at least try to get through, what time is it? 4 and 5. Let's try to get through 4 and 5. Then we'll stop. 8 cosine of x minus 1 equals 0. All right, these are the easiest ones. All right, guys, this is algebra. Everybody look, this cosine of x is one term. It's together. It stays together always. I can add 1 to both sides, though. So that is 8 times the cosine of x equals 1. And then divide by 8. So now the cosine of x equals 1/8. How do I solve this?
Swap the extreme. No, you don't.
Inverse. Inverse cosine 1/8 equals x. Is 1/8 on the unit circle?
No.
So you're going to do this in your calculator. What quadrant are you going to be in? First. That's right. Okay. So what is x? X equals
1.4455 plus 2.
Is there another solution? What is it?
Negative.
Negative 1.4455 plus 2k pi. Got it? Okay, we're going to do number 5. Look at it. The sine of u equals square root of 2 over 2. Is that on the unit circle?
Yes.
So what is u?
Pi over 4.
All right, so u is pi over 4 plus 2k pi. Is there another one?
Yes.
How do I find it?
So you do pi minus pi over 4.
Here, pi minus pi over 4. That's, do you see that? I'm taking the pi, it's u equals, and then I'm going to do pi minus what I just got, plus 2k pi. This is 3 pi over 4. And I have my 2 solutions. You see why inverse operations are so important?